going to talk about today is our flexible antenna development. Just with a quick show of hands, who all in the room is using flexible antennas? So a couple of people, yeah. I think I have all the slides from those sites on this. So real quick, yeah, what am I doing? Just forward. So the impetus for the development of the flexible antenna system was the Pile Dyke PD7 site that's in the Lower Columbia. So the Pile Dyke structures, I think there's 233 of them from Rockville out to the mouth. And it just keeps sediment and the channel flowing. These are a string of pilings projecting out into the river, which actually do a pretty good job of accumulating the fish that travel down them and then out and around. So we have a site at the end of PD7. So this is back in 2012, where it was a muck and there's an antenna array at the end of it. They're your standard 4-foot by 10-foot PVC pipe antennas, and then antennas on the pile dyke itself. So started to notice in the data that fish would be detected on these coils, but never detected passing through the antenna array on the end. So back that up with some distant data that showed, yes, in fact, fish would come in, they would see this obstruction at the end, they would circle around, travel out past the wing wall, and never get detected on those end antennas. So about that time, the IS 1001 came out, which obviously is more stable than the MUX. Has a wider tuning range, which would allow it to accommodate a flexible antenna system. More powerful, so we could drive a bigger antenna, and has a lower inductance, so it's going to change less with those changes of the windings when they move. So back in 2012, I put together a quick 10-foot by 10-foot just to test it out, and we were getting 40 inches of read range with just regular 8-gauge copper wire. So we came up with a plan that we would build 8-foot by 20-foot antennas and replace the array on the end, so it would be less of an obstruction, and then with the master controller that would allow us to do more antennas down the pile. But transporting an 8-foot by 20-foot antenna out to the end of the pile dyke on skiff was problematic, so we started to look at, could we do this with flexible hose? So in thinking of that, our Pasco shop put together, we did 107 tests on antennas in general to figure out what was the driving factor. So we tested different wire gauges, wire proximity with the windings relative to each other, wire layout, whether it made sense to have them all flat or could we do them in a triangle, and the insulation properties of the wire itself. So the two big takeaways from that 107 tests was wire insulation actually does play a pretty sizable part in the detection field. And when you're talking about a big antenna like that, we have to stay above, I think it's roughly 7 amps, or we start to get a hole in the middle of it. So anything we can do to eke out the last of the read range of those big pass-through antennas, we were going to do it. So FEP versus PVC insulation, and when I talk about insulation, I mean actually on the wire itself, we had a 5.3% difference in the antenna current. And what we figured out is the relative permittivity of PVC is 3, and the FEP is somewhere around 2.1. And that means that in the insulation jacket of the winding itself, you're actually losing power by polarizing that insulation. And by going with the lower dielectric insulation, we were able to increase the antenna current. And also wire separation. So even just a little bit of separation between the windings inside the antenna made a pretty significant increase in our read range. So the Jones Beach crew, Dick Ledgerwood, Matt Morris, and the group down there put together a prototype antenna. They painstakingly hot glued together this foam backer rod from Home Depot and made a triangle. And then in those grooves, they put 3 10-gauge lift wires, wrapped the whole thing in cellophane, and slid it inside of a 3/4-inch hose. And it worked really well. We installed those on the pile dyke, and they also built a flexible antenna array that I'll show you in a minute that they're actually towing up the Columbia River. So in 2015, the Northwest Fisheries Science Center, where I'm at, we worked on a project with the Southwest Fisheries Science Center in the lower Sacramento Basin. And our part of it was to develop detection in a big body of water, much like the lower Columbia. So with this parallel development, it allowed us the funding to go out and source a flexible antenna cable that we didn't have to glue back or on together. So I shopped the idea around to a couple of different custom cable manufacturers and ended up landing on this FowlNet cable, which had the 10-gauge lift wire and everything inside here, the insulation, the spacers, it was all selected to be as low a dielectric as possible. And it allowed us spacing between the winding and the water. And then it was coated with this outer jacket that was durable and waterproof. It's expensive. When we bought it, we bought the like 900 feet of it and it ended up being $19 a foot. But that's only a little over $1,000 for a 20-foot by 8-foot antenna. And there's no labor involved in constructing it. So, and it worked pretty well. So here's a picture of the cable, the first batch of cable we got, and a picture on the back deck of one of our skiffs with the hose antennas compared with the manufactured antenna. So we did deployments in the lower Columbia and compared the hose antenna to the fabricated and flexible antenna, and saw that the fabricated antenna works only slightly better than the best hose antenna, but across the board they all worked about the same, and there was some deviation in how the hand-built hose antennas perform. So these are the three general deployment strategies for the lower Columbia project, where they have 8-foot by 20-foot antennas all strapped together like a big net, and they're pulling it up the river. Yeah, here's a picture of it. You can see the CAN bus power cable trailing out behind the flexible antenna. So some of the issues we've dealt with the flexible antenna system, we lost almost the entire season because when we deployed anything more than 11 antennas, we would start to see a loss of data coming back from the IS-1001. It would no longer report noise or antenna current, and we thought for a while that we were actually, something was going wrong with the IS-1001. Turned out it was a firmware timeout issue. We exceeded 2 seconds getting back to the first antenna, then we were losing communication. So we talked to Biomark, and within 45 minutes of that call, we received an updated firmware version that solved that. But we're still struggling with some noise. When we first deployed this, when we deployed it last in 2017, it worked pretty well with plugins. This last season, we struggled with noise, and it appears that it's just that CAN bus cable isn't very tough, and repeated deployments from the back of the skiff have probably damaged the insulation in there. I don't know if anybody's cut that open, but it's just foil insulation around the CAN bus wires and the power wires, and then the whole bundle. So I put together a new CAN bus cable. We put out a contract. We should have it next couple of weeks, and we'll begin testing this. The plan B, if that doesn't fix it, I've also tested replacing the CAN bus with fiber optics. So at the master controller, there's a converter that converts the CAN over to fiber, and that would shoot out to the first reader and get transferred back in the CAN bus. I've tested it with one IS-1001, and it works. I'm waiting for my second IS-1001 to come back from Biomark to test multiples. But that would still leave the possibility to couple on to power. So this issue that we're seeing is likely very similar to anybody out here that's put a master controller in the river. And if you put the CAN bus cable directly up against the antennas, you'll lose current and you'll see noise. And that effect is exaggerated with these big antennas that we're using, big flexible antennas. So another possibility would be to eliminate all the copper between everything and power the readers with batteries and have fiber run between them. Obviously, that wouldn't work for in-stream application, but what we're doing in the lower Columbia, we would then just retrieve it and replace or recharge the batteries. And we've struggled a little bit with enclosures, but I think we've solved pretty much the enclosure issue. So this is the CAN bus cable that we've had developed. As I mentioned, instead of just the foil, there's braid, and a drain wire, and then all of that is mylar taped. So we'll have better isolation between the different grounds. I think what's happening is the shield coating is breaking down over time, and that is creating ground loops in the system that's causing noise. So I told you all that to tell you this. So the flexible antennas work for what we're doing, but there's not a whole lot of people with skiffs and trawl dragging stuff up the Columbia River. But this is a couple of pictures of Reagan McBath site in the lower Columbia Estuary. Obviously, there's not a whole lot of trees and stuff coming out of that, so she's able to have the antennas situated like this. But that, regardless of water level, you're getting every fish that passes through there. And this is one of Zach Mays' sites where the stream is small enough to be able to cover the entire thing with the flexible antenna. You're looking at cost, and if you're really concerned with juvenile detection and you need the entire stream, regardless of water level, to have detection, I think this may be a solution. And with that, I'd like to thank mainly the group down at Jones Beach. They've done all the heavy lifting with this. I'm being just at my office. I'm like, hey, try this, see if it works. And they've done all that, and they've pretty much made this system work. And then Bonneville Power Administration and the Corps for all their help on it. So with that, that's my contact information and email. If anybody has any questions, they want the cut sheet on the cable or contact information for FoulNet or a part number. Part of my salary is funded by Bonneville for pit tag support in the Columbia Basin. So if you guys ever have a question and need somebody, certainly shoot me an email or give me a phone call. Does anybody have any questions?